Hello, students, and welcome to our lesson on the quadratic formula. This is going to conclude our final way to solve quadratics, which means to find where a quadratic equals 0, where it crosses the x-axis on the coordinate plane. We've talked about graphing, factoring, completing the square, and now we're going to use the quadratic formula, which is this: x equals, and in the numerator, negative b plus or minus the square root of b squared minus 4ac divided by all of that, divided by 2a. So as you apply the quadratic formula, there's a couple of things I want you to keep in mind that are kind of important. And if you follow them very carefully, you'll be very successful as this. You can use the quadratic formula to solve a quadratic equation when some of the other methods that might seem easier to you or that you might be more used to don't seem to work, because those won't always work. And we'll be talking about that in the next couple of days, how to choose which way to solve a quadratic equation. So we have our example here. X squared minus 5x minus 36 equals 0. And that takes us to step one, which is to make sure that the equation is set to 0 and that it's in standard form, that ax squared plus bx plus c equals 0. And then you want to identify a, b, and c. So in this case, a equals 1, b is negative 5, and c is negative 36. And then you're going to substitute those values into the formula, and the tricky part will be to be very careful when you simplify. So let's start with the first example here. We have identified our a, b, and c values. We already had it in standard form. So x equals, and that will be 5 plus or minus the square root of, and you need to make a nice long radical. So it will be, so we have b squared. So our b is negative 5. Make sure you use parentheses very carefully, please. Negative 5 squared minus 4 times 1 times negative 36. And all of that will be over 2 times our a value, which is 1. So we'll just continue to simplify that. So we have the 5 plus or minus, and we've got 25 plus 144. All of that over 2 times 1, which is 2. And then x equals 5 plus or minus the square root of 169. All of that divided by 2, which will equal 5 plus or minus 13 divided by 2. And when we evaluate that, we have our two answers, negative 4 and 9. So that's the basic steps, and that's how it's done. So let's do some of these problems together. I think I'm going to make the page a little bit bigger, give us a little bit more room to work. So, okay. So our a value here is 1. Let's make my line a little thinner. Our b value is negative 8, and our c value is 20, negative 20, because we have to put this in standard form. There we go. So it's negative 20. All right, so now we'll substitute. Remember, you need a nice long radical. Your division bar or your vinculum has to span the entire length of this, and then you'll have 2 times the a value, which is 1. So there we've made our substitutions carefully and accurately, using parentheses as we go. So now we'll begin simplifying this little by little, bit by bit. So this will be 64 plus 80 all of that divided by 2. So that would be 8 plus or minus the square root of 144. Again, all of that divided by 2, which will be 8 plus or minus 12 divided by 2, which will equal -2 or 10. And you can check these by plugging them into Desmos and seeing if this works. So let's rewrite this equation number 2. We'll rewrite this as 2x squared plus 7x minus 9, because we brought that 12 over, equals 0. So our a value is 2, our b value is 7, and our c value is -9. And then we'll make our substitutions. So be careful with the, remember it's -7 here because we have a +7. Last time we had a negative b value. So the formula itself is -b plus or minus. So let's get that straight. Now radical. So it would be 7 squared minus 4 times 2 times -9. All of that over 2 times 2. And then we'll start simplifying. That'll give us 49 plus 72. And 2 times 2, of course, is 4. And we'll simplify further. X equals -7 plus or minus. Now we have the square root of 121. All of that divided by 4. And let's move our paper down a little bit. I think I can squeeze another row in here. So -7 plus or minus square root of 121 is 11 divided by 4. And then our final answer will be, we're going to have a fraction -9 over 2. And remember, we leave the improper fractions or 1. And that's our final answer. So let's go on to number 3. So we can rewrite this, but our c value is still going to be 0. I'm sorry, our b value is going to be 0. Our c value is -12. So actually, we don't need to rewrite that. We can just leave it as is, but we do need to put our a, b, and c. So our a is 3. We don't have a b value, so we'll call it 0. And our c is -12. So let's start with our substitutions. X equals, so it will be 0, remember, is neither positive nor negative. So 0, I'm just going to put it in parentheses just to show you how important it is to use parentheses. Right, and let's start evaluating that. So it'd be 0 plus or minus the square root of 0 plus 144 divided by 6. So x equals the square root of 144 divided by 6. And when we evaluate that, the square root of 144 plus or minus will be plus or minus 12 divided by 6. And when we evaluate that, Negative 12 divided by 6, or positive 12 divided by 6 will be plus or minus negative 2. So we can just write that just like this, plus or minus 2, and we're done. So that one was a little bit easier than some of the others. Number 4, x squared plus 15x equals 6x. So we need to move the 6x over to the left, which means we'll be subtracting it from 15, which gives us x squared plus 9x equals 0. So we don't have a c value this time. Our a value is 1. Our b value is positive 9. So we'll start our substitutions. So it's negative 9 plus or minus the square root of 9 squared minus 4 times 1 times 0. Okay, all of that divided by 2 times 1. And we'll start simplifying that. Negative 9 plus or minus, and this will be 81 plus 0. All of that divided by 2 times 1, which is 2. And simplify further, plus or minus. So 81, the square root of 81 is going to be plus or minus 9. So we don't need the radical there. And all of that divided by 2. So negative 9 plus 9 will be 0 divided by 2, which will be 0. Positive 9, negative 9 minus 9 will be negative 18 divided by 2, which will be negative 9. So our two values will be negative 9 and 0. And you're going to get some good integer work here as you work these problems. So number 5, let's see, negative x squared minus 10x minus 21. It's already in standard form. We're okay with that. Our a is negative 1, our b is negative 10, and our c is negative 21. So let's start our substitutions. X equals, so negative 10, the negative of negative 10 is positive 10. So it's 10 plus or minus, we need a nice long radical, parentheses, negative 10 squared minus 4 times negative 1 times negative 21. All of that over 2 times negative 1. And let's start simplifying. So in the numerator, we'll end up with 100 minus 84 divided by negative 2. And 100 minus 84 is 16, which is a perfect square. We like that. Which gives us 10 plus or minus 4 divided by negative 2, which when evaluated gives us the set negative 7, negative 3. And number 6, we have to move 12x to the left side, so it will be 9x minus 12x, so it's going to be 4x squared minus 3x. We don't have a c value, equals 0. So our a equals 4, our b equals negative 3, and our c equals 0. So let's do our substitutions. X equals 3 plus or minus, nice long radical, in parentheses, negative 3, then we square the whole thing, minus 4 times 0, all of that divided by 2 times the a value of 4. Then we begin to simplify, 3 plus or minus, and what we'll have is square root of 9 plus 0 divided by 8. 2 times 4 is 8, which will give us 3 plus or minus, because 3 is the square root of 9 plus 0. All of that divided by 8. When we evaluate those individually, we have 0, or when reduced, a fraction of 3/4. So that's the first 6. So let's continue with the second page. I'd love to see you try a few of these on your own. I think that would be really good practice for you. At least try 7 and 8 on your own before we go on to the irrational ones. Okay, so for number 7, we will write that in standard form, x squared, and that will be plus 6x plus 10 equals 0. So our a value is 1, our b value is 6, and our c value is 10. All positive numbers. So let's make our substitutions. X equals -6 plus or minus the square root of, and that would be 6 squared minus 4 times 1 times positive 10, that shouldn't be a negative, times positive 10. All of that divided by 2 times 1. And as we begin to evaluate that, we have -6 plus or minus the square root of 36 minus 40 divided by 2 times 1, which is 2. And as we continue to evaluate this, -6 plus or minus, we have the square root of -4 divided by 2. Well, we cannot have a negative square root. So we stop right here, and we know that there is no solution to this problem. Okay, see, empty set. No negative square root. Okay, number 8, we will rewrite this in standard form by moving the -3x over. That makes it a positive 3x to give us 6x squared minus 5x. And we move the 4 over. It will be -4 equals 0. And let's start our substitutions. X equals 5 plus or minus a nice long radical. So we have -5 squared minus 4 times 6 times -4. And I should have identified my a, b, or c. So my a equals 6, my b is -5, and my c equals -4. All right, let's continue simplifying. X equals 5 plus or minus, and that would be 25 plus 96. All of that over, and I forgot to do that part up here, 2 times 6, so that will be 12. And now we're going to add the 25 and 96. To give 121, which will be, the square root of that will be 11. So that would be 5 plus or minus 11 divided by 12, which will equal, we'll have two fractions this time. It's going to be either -1/2 or +4/3. Now let's move on to the irrational problems. So we have x squared minus 4x plus 1 equals 0. A equals 1, B equals 4, C equals 1. So let's plug and chug. X equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 1, all of that over 2 times 1. And let's keep evaluating. X equals negative 4 plus or minus the square root of 16 minus 4, all of that over 2, and 16 minus 4 is 12, which is not a perfect square. Okay, you can't just divide that 12 in a radical by 2. Okay, we need to evaluate. We can think of that 12 as square root of 12. We can think of that as the square root of 4 times the square root of 3. Yeah, that's the way we're going to do it. So, and that is since implied multiplication between their students. So we will rewrite that. X equals negative 4 plus or minus. So we have the square root of 4 times the square root of 3, all divided by 2. And we'll evaluate it further. Negative 4 plus or minus 2 times the square root of 3. So the square root of 4 is 2. All that divided by 2. And when we evaluate this, we will have x equals negative 2, because negative 4 divided by 2 is negative 2, plus or minus the square root of 3. And that's our final answer. Just like we've done other irrational quadratics. So number 10 is also written in standard form. A equals negative 1, B equals negative 2, and C equals 7. So let's make our substitutions. X equals 2 plus or minus. Remember, B is negative 2, but the B in the formula is negative, so it's a negative times a negative is a positive 2. We need a nice long radical here. Our negative 2 will go into parentheses. We'll square it. Minus 4 times negative 1 times 7. All of that divided by 2 times negative 1. And let's just begin simplifying. 2 plus or minus square root of 4 plus 28 divided by negative 2. X equals 2 plus or minus square root of 32, all divided by negative 2. And we can think of the square root of 32. We're going to think of that as 16 times 2. So the square root of 16 is 4. So that would be 2 plus or minus 4 times the square root of 2 divided by negative 2. I'm going to rewrite that x a little bit to the left so it's easier to understand. Actually, I'll move the equal sign too. Yeah, that's a little clearer. Okay, so when we evaluate this, when we divide this positive 2 by negative 2, that's going to be negative 1. And when we divide the 4 by negative 2, the plus or minus will take care of the plus or minus we have when dividing. So when we evaluate that, we'll end up with -1 plus or minus 2 times the square root of 2 as our final answer. Let's do number 11 next. They just do take a little bit of practice and a steady hand. So it looks like it's in, let's see, we're going to have x squared. We have a little bit of moving things around to do, plus x minus 11. Because when we move 9 over as a negative, we will have -20 plus 9, which will give us -11 equals 0. So our A is 1, our B is also 1, and our C is -11. So let's start doing our substitutions. So we will have -1 plus or minus a nice long radical. So -1, or sorry, not -1, that's a +1. 1 squared minus 4 times 1 times -11. All of that over 2 times 1. So now as we evaluate that, -1 plus or minus the square root of 1 plus 44 all over 2 times 1, which is 2. So that'll give us -1 plus or minus square root of 45 all over 2. And when we evaluate this, we can think of this as the square root of 45 as the square root of 9 times the square root of 5. And the square root of 9 is 3, so that will give us x equals -1 plus or minus the square root, 3 times the square root of 5 divided by 2, and that is our final answer. Can't reduce that any further. That's as much as we can simplify that. So let's rewrite number 12. We have to move the -2 over. So that would be 4x squared minus 7x equals plus 2 equals 0. And our A value is 4, our B value is a -7, and our C value is a 2. So let's start making our substitutions and working our problem. X equals 7, because -7, the negative of -7 is a +7, plus or minus square root of -7 squared minus 4 times 4 times 2, all of that over 2 times 4. And we'll start simplifying. So we've got 7 plus or minus the square root of 49 minus 32, and 2 times 4 is 8. We'll keep simplifying. We've got 7 plus or minus 49 minus 32 is 17. So we have the square root of 17 divided by 8. And there's nothing else we can do to simplify this. We cannot, 17 is a prime number. There are no factors, let alone any perfect square that we can multiply by anything else to get to 17. So that's our final answer right here. So 2 more. Why don't you try them yourself and then come back and see how you did. So let's write this in standard form. So x squared minus x squared comes over, becomes positive, gives us 2x squared minus 8x plus 3 equals 0. A equals 2, B equals negative 8, C equals 3. So x equals, and negative 8, negative times a negative is a positive. So that would be 8 plus or minus, nice long radical, negative 8 squared minus 4 times 2 times 3. All of that over 2 times 2. And we'll begin to simplify. So negative 8 squared is 64. All of this is 4 times 2 times 3 is 24. So 64 minus 24 divided by 4. So we have 8 plus or minus the square root of 64 minus 24 equals the square root of 40, which we divide by 4. And we can think of 40, let's think of that as 4 times 10. The square root of 40, the only perfect square we can get in there is 4. So square root of 4 times the square root of 10. So we have 8 plus or minus the square root of 4 is 2 times the square root of 10 divided by 4, which equals, when all is evaluated, said and done, in our numerator, we will have 8 divided by 4, which is 4, plus or minus. This will become 2 over 4 becomes 1/2, so the 1 becomes an invisible 1. So we've got the square root of 10 divided by 2, and that's our final answer. And then our last problem today, we need to move the 12 over, which will make it a negative 12. So our problem will be 3x squared minus 6x minus 12 equals 0. And our A equals 3, our B equals negative 6, and our C equals negative 12. So let's start substituting. X equals, and since we have a negative B, it will be positive here, 6 plus or minus, nice long radical sign, negative 6 in parentheses, squared minus 4 times the A value times the C value. And all of that is divided by 2 times the A value. And then we just begin to simplify. So we've got positive 36 plus 144 divided by 6. Let's continue to simplify. So 36 plus 144 is 180. And we can think of the square root of 180 as the square root of 36 times the square root of 5, because 36 times 5 are 180. So x equals 6 plus or minus 6, the square root of 5, divided by 6, which we can simplify nicely to 1 plus or minus the square root of 5. So you have for homework, I'd like you to try a few of these. We've got We've got 2 pages for you to get some practice. Here's your quadratic formula right there for reference. Be sure to use parentheses and be sure to make your substitutions and your evaluations very, very carefully. Go back over the ones that we practiced in class. And remember, as always, with practice, you'll be great.